642 is all about using the calculator to aid in simplifying radical expressions. So we'll use the calculator as much as we can. If you take a look at 1 through 3, all of these can be put into the calculator. So go ahead, pause this, and take a second to do so. Okay, so the idea is if you use your calculator, you can type these in the way that you see them, and the answer should come back out. So go ahead and take another second and type them into your calculator. The calculator can aid you a lot of times, but sometimes it's not an answer that's put in radical form, and the directions will want them in radical form. When you take something that should be a radical and you make it a decimal, you're rounding, and every time you round, you add some error to the problem. So we're going to look at some problems where you can switch to exponential form, and it'll help you find a more reliable answer. Just a quick recall on some algebraic concepts in terms of exponents. If you are multiplying something that has an exponent with the same thing that has a different exponent, you add them. So that's the first example. X to the m times x to the n means you keep the x and add the m and n. I do want to clarify, you keep it. Whatever that big base number or letter is, that stays the same and doesn't change. In that second line, if you're dividing something on the top and the bottom of a fraction that has an exponent, you keep the big base, in this case that's an x, and you subtract the exponents. And the last one says that if you have something raised to a power, like if you have x to the m, and you raise that to another power, you multiply what's in the air. So if you don't want to use the calculator, you can use the law of exponential form in order to go back and forth between radicals and exponents that'll allow you to solve. So if you take a look at number 1, we can't change that to a radical, because if we do, we would have the cubed root of 7 times the square root of 7, and the index wouldn't match. So a really big hint is if these big numbers match, you keep those big numbers, in this case it would be a 7, and you add the exponents, and use your calculator to do that. 1/3 plus 1/2 is 5/6. Now, the directions specifically say that you have to write your answer in radical form, so you do need to change that 7 to the 5/6 into a radical. Remember that that bottom number stays out and the top number goes inside. So you should be using your calculator to figure out 7 to the 5th, which happens to be 16,807. This is your final answer. In number 2, it's quite the opposite. In radical form, because the index of the first one is a 2 and the index of the second one is a 3, you can't figure it out using the laws of radicals. But you can switch it into fractional exponents instead. So instead of this problem, make it a 5 to the 1/2 times a 5 to the 1/3. And because those 5s match, you keep the 5 and you add the 1/2 and 1/3. 1/2 plus 1/3 is 5/6. Again, they want you to put your answer in simplified radical form, and the bottom number stays out, top number goes in. So this is the same as the 6th root of 5 to the 5th. And 5 to the 5th is 3,125. In number 3, you can't do this in radical form because the index doesn't match. The top is a square root, the bottom is a cube root. So take a second and rewrite them using fractional exponents. That would be 7 to the 1/2 over 7 to the 1/3. And because the 7s match, you keep the 7, and in this case we end up subtracting the exponents because in division we subtract. And use your calculator to do 1/2 minus 1/3, should give you 1/6. In radical form is the 6th root of 7. And number 4, again, because the index doesn't match, change them to exponential form instead. That's the same as 4 to the 1/3 on the top, and 4 to the 1/6 on the bottom. Because those 4s match, you keep the 4 and subtract the exponents. 1/3 minus 1/6 is 1/6. In radical form is the 6th root of 4. In number 5, you're looking at a power raised to a power. That 2/3 is being raised to the 6th power. So the rule says keep the x and multiply the numbers in the air. In this case, we're multiplying 2/3 times 6, and that gives you 4. X to the 4th. Anytime your exponent is an integer, you can't rewrite it using radicals. So because that 4 is an integer, specifically speaking a whole number, you can't put it in simplified radical form. It just stays like that. Number 6, I know it's hard to see on here, but I do believe that's a negative. So if I take x to the negative 1/4 and square it, I multiply the exponents. Negative 1/4 times 2 is a negative 1/2. You're not allowed to leave exponents as negatives. So anytime you have a negative exponent, it pushes it into the denominator. So I really have 1 over x to the 1/2. This one's kind of tricky, and students often overlook what you really have. Anything to the 1/2 power is really the square root. So 1 over x to the 1/2 is really this 1 over the square root of x. And you can't leave it like that. Remember, you can't have radicals in the bottom or bottoms in radicals. So you have to rationalize it. We can rationalize this by multiplying top and bottom by the square root of x. The bottom becomes the square root of x squared, which is just x. On the top, you have 1 times the square root of x, which is the square root of x. You can't simplify that. But keep in mind, on the bottom of that fraction, you did start even and end odd, so you need absolute values. Your final answer ends up being the square root of x over the absolute value of x. In number 7, this power goes to both parts inside the parentheses. So we'll do one at a time. Power to power means you multiply. For the x, if I multiply 2/3 times negative 6, I get negative 4. And for the y, if I multiply negative 1/3, that's hard to see, but there's a negative there, negative 1/3 times the negative 6, I get a positive 2. This negative 4 right there can't be negative. So I'm going to allow the y squared to stay, positive and okay, but I'm going to push that negative 4 into the denominator where it will become positive. Because the 2 and the 4 are whole numbers, you don't write it in radical form. So if the directions for these say radical form, then you should be switching them. In the very first one, this is the same as the 4th root of 125 because it's 5 cubed inside. In the second one, this is the same, This is the same as the 12th root of 4 to the 7. And if you use your calculator for that, you would get 16,384. In letter C, this is the same as the 15th root of x. In letter D, that's the same as the 12th root of 3. And letter E, those are exponents that are whole numbers, so they can stay.